The shocking truth behind Junkers Jumo 004 turbojet engine reveals aviation's deadliest deception. The world's first mass-produced jet engine that promised to revolutionize aerial warfare. This groundbreaking power plant thrust the Messerschmitt Me 262 into history as the first operational jet fighter, screaming through the skies at speeds that left Allied pilots stunned. But behind this technological triumph lurked a catastrophic secret. The Jumo 004 wasn't the wonder weapon Nazi propaganda claimed. It was a death trap with a deliberately hidden 25-hour lifespan that sent German pilots to their graves through engine failure at rates that shocked even hardened Luftwaffe commanders. By 1944, the Third Reich was bleeding. Allied bombers darkened German skies daily, and the Luftwaffe's propeller-driven fighters couldn't stem the tide. Germany needed a miracle, something that could leap past conventional aviation and reclaim air superiority through sheer technological supremacy. The answer came in the form of the turbojet, a radical new concept that would abandon pistons and propellers for pure jet thrust. Hans von Ohain and Herbert Wagner at Junkers had been racing against Frank Whittle in Britain to perfect this technology. The pressure wasn't just professional, it was existential. Without air superiority, Germany would burn. The Jumo 004 emerged from this crucible of desperation, an engine born not in methodical development, but in the fevered rush of a collapsing empire. What followed would become one of aviation's most controversial chapters, a story of brilliant engineering corrupted by impossible deadlines, slave labor, and a leadership willing to sacrifice its own pilots for propaganda victories. The Jumo 004 was nothing like any engine that came before it. Where the Merlin and DB605 relied on pistons hammering away at 3,000 RPM, the 004 spun at a terrifying 8,700 RPM, sucking in air through its gaping intake and compressing it through an 8-stage axial compressor. This wasn't evolution, it was revolution. The engine weighed just 745 kilograms, yet produced 1,980 pounds of thrust, enough to push the Me 262 past 540 miles per hour. Making it nearly 100 miles per hour faster than the best Allied fighters. Inside this aluminum beast, temperatures reached 800 degrees Celsius. The combustion chambers roared with a continuous explosion that sounded like nothing pilots had ever heard. Not the rhythmic bark of pistons, but a sustained shriek that seemed to tear the air itself apart. The turbine blades, each one precision cast and hand-finished, spun so fast they approached the speed of sound at their tips. This was the heart that powered the Me 262 Schwalbe, the Arado AR-234 Blitz bomber, and even the desperate last-ditch Henkel HE 162 Volksjäger. The engineering principles behind the 004 represented a complete paradigm shift in propulsion thinking. Instead of using mechanical energy to turn a propeller through the air, the turbojet created thrust through pure reaction force. Air entered through the intake at 500 pounds per second, was compressed to 8 times atmospheric pressure, mixed with J2 synthetic fuel derived from coal, and ignited in 6 separate combustion chambers arranged around the engine's circumference. The resulting explosive expansion drove a single-state turbine that in turn powered the compressor, creating a self-sustaining cycle of controlled destruction. The starting procedure alone revealed how alien this technology was to conventional aviation. Pilots had to use a 2-stroke Riedel starter motor mounted in the nose cone, pull starting it like a lawnmower to spin the turbine up to 2,000 RPM before fuel could be introduced. Too much throttle too quickly would cause a compressor stall, shooting flames 30 feet out the exhaust. Too little and the engine would simply refuse to light. Ground crews called it waking the dragon. And like dragons, these engines were temperamental, dangerous, and utterly unpredictable. When test pilots first opened the throttles on a Jumo 004, they described it as controlling thunder itself. The acceleration was instantaneous, brutal, and intoxicating. No propeller lag, no torque effects, just pure savage thrust that pinned them to their seats. Fritz Wendell, the Me 262's chief test pilot, said flying with the 004s was like being shot from a cannon that never stopped firing. This was the future of aviation, condensed into a tube of spinning metal and fire. If you're fascinated by these revolutionary engines that changed warfare forever, hit subscribe now. We uncover the hidden stories behind aviation's most controversial machines, where engineering brilliance meets human tragedy. The Jumo 004's development story reads like a fever dream of impossible challenges and desperate solutions. When Anselm Franz took over the project in 1939, jet propulsion was still theoretical madness to most engineers. The BMW 003, their main competitor, was failing spectacularly. The HE-S8 from Henkel had literally exploded on the test stand. Franz had to create not just an engine but an entirely new field of engineering. The first prototype, 004A, used all the best materials: nickel, cobalt, and molybdenum alloys that could withstand the hellish temperatures inside the turbine. These early engines ran beautifully, achieving over 100 hours of operation. But by 1941, Germany's strategic materials situation was catastrophic. The Reich had no nickel. Cobalt was worth its weight in gold. Every gram of molybdenum was fought over by competing industries. Franz was ordered to redesign the entire engine using only materials Germany could actually obtain. The 004B that resulted was a masterpiece of compromise and clever engineering. Hollow turbine blades made from folded sheet metal replaced solid cast ones. Mild steel substituted for heat-resistant alloys. Air cooling channels snaked through components that should have been solid metal. Franz even developed a revolutionary aluminum coating process to protect inferior metals from oxidation. The turbine blade manufacturing process itself became an art form. Each blade was made from Tinador steel, folded into complex cooling passages, and welded with a precision that pushed 1940s manufacturing to its absolute limits. Yet even this ingenious design couldn't overcome the fundamental problem. These materials simply weren't meant to withstand the forces inside a jet engine. But these weren't just material challenges. The production facilities themselves were under constant bombardment. Junkers moved production underground into salt mines and railway tunnels. Workers, many of them forced laborers and prisoners, assembled engines by candlelight when the power failed. Quality control became a sick joke. Tolerances that should have been measured in thousandths of an inch varied by whole millimeters. The Reich Aviation Ministry didn't care. They wanted jets in the air, and they wanted them immediately. When Franz protested that the engines needed another year of development, he was told that Germany didn't have another year. Build them now, test them in combat. The pilots would have to be the final test program. Despite everything, when the Jumo 004 finally reached operational units, it delivered moments of stunning success that shocked the Allied air forces. On July 25, 1944, the lone Me-262, powered by two 004s, encountered a formation of de Havilland Mosquitoes, the RAF's fastest aircraft, previously untouchable by German interceptors. The jet closed on them like a shark among minnows, destroying one before the others even realized they were under attack. The first major combat development came with Commando Novotny in October 1944. Major Walter Novotny, already an ace with 258 victories, took his jets up against massive bomber formations. The results were electrifying. The 004-powered Me-262 slashed through escort screens, ignoring P-51 Mustangs that couldn't match their speed. They'd dive on bomber formations at 600 miles per hour, unleashing rockets and cannon fire, then zoom climb away before gunners could track them. Allied pilots were genuinely terrified. Chuck Yeager himself, who would later break the sound barrier, described his first encounter with a 262. "The first time I saw a jet, I shot it down. It went by me and I pulled up into a hammerhead stall, fell over and got him. But Jesus, that thing was fast. If they'd had experienced pilots and reliable engines, we'd have been in serious trouble." For brief moments, the Jumo 004 lived up to its promise. On March 18, 1945, 37 Me-262s from JG-7 attacked a formation of 1,221 bombers and 632 fighters. In minutes, they shot down 12 bombers and one fighter, losing only 3 jets. These were kill ratios that conventional fighters could only dream of. The 004's distinctive howl became the sound of death approaching at unprecedented speed. But here's where the story turns from triumph to tragedy. What the pilots flying these revolutionary machines didn't know, what Junkers and the Nazi High Command deliberately concealed, was they were sitting on time bombs. The Jumo 004B's operational life wasn't the 100-plus hours of the prototypes. It was 25 hours, sometimes less, sometimes catastrophically less. The inferior materials Franz had been forced to use created a cascade of failure. Turbine blades made from folded sheet metal instead of proper alloys would creep and deform under the extreme centrifugal forces. When one blade failed, and they always failed, it would tear through the engine like shrapnel, destroying everything in its path. The engine wouldn't just stop, it it would explode. The temperature management system was particularly diabolical in its unreliability. The 004 required precise temperature control during all phases of flight, but the throttle response was so poor that pilots had to anticipate power changes by several seconds. Move the throttle too quickly, the engine would surge, potentially catching fire. Move it too slowly during combat, and you'd be a sitting duck. The engine temperature gauge was known as the death clock. Pilots would watch the needle creep toward the red zone, knowing that each degree brought them closer to catastrophic failure. The official manual claimed the engines could handle brief temperature excursions, but mechanics knew better. They'd seen the melted turbine blades, the burn-through combustion chambers, the engines that looked like they'd been destroyed from within by some terrible force. But the material failures were only part of the horror. With the thousands of Jumo 004s produced, historians estimate that a significant percentage were compromised by systematic sabotage. The slave laborers building these engines, French prisoners, Polish deportees, concentration camp inmates, knew exactly what they were building and who would fly them. They filed turbine blades just enough to weaken them. They mistorqued bolts. They contaminated lubricants. They scratched microscopic flaws into critical components that would fail under stress. One technique involved using urine to corrode critical components in ways that wouldn't be detected during inspection, but would cause failure after a few hours of operation. Another involved deliberately misaligning compressor blades by fractions of a millimeter, causing vibrations that would eventually shake the engine apart. One French prisoner interviewed after the war admitted, "We knew those engines would kill German pilots. That was the point. Every engine that failed was our small revenge." The SS guards supervising production knew about the sabotage but couldn't stop it. How do you force precision from enslaved laborers that have nothing left to lose? The pilots were never told. Official Luftwaffe doctrine stated that the Jumo 004 was reliable for 50 hours of operation. Training materials claimed even longer. Pilots would take off for combat missions believing they had dependable engines, only to have them fail catastrophically over enemy territory. Or worse, on takeoff when they were the most vulnerable. The statistics paint a damning picture. Engine-related failures claimed a staggering number of Me-262s. Flameouts on takeoff killed dozens. Turbine explosions at altitude killed more. Pilots who survived would report sudden vibrations, then a bang, then nothing, if they were lucky. If they weren't, the exploding turbine would sever control cables or rupture fuel lines, turning the aircraft into a funeral pyre. The true story of the Jumo 004 story reached its peak during Operation Bodenplatte on January 1, 1945. The Luftwaffe launched its last major offensive, throwing everything into one desperate attack on Allied airfields. The Me-262 units were held in reserve, waiting for their moment. When they launched, the massacre began, not from enemy fire, but from their own engines. Oberleutnant Hans Waldmann's engine exploded on takeoff, cartwheeling his aircraft into a line of parked fighters. Hauptmann Franz Stigler lost both engines over enemy territory and spent 4 hours evading capture after crash landing. Major Heinz Baer, one of Germany's greatest aces with 220 confirmed victories, had to abort 3 separate missions due to engine failures. His diary from this period reveals the psychological toll. We fear our own machines more than the enemy. Every takeoff is Russian roulette. The Allied intelligence services had figured it out by then. Captured Me-262s revealed the truth about the 004's lifespan. RAF pilots were instructed to simply avoid the jets during their attack runs and wait. Don't chase them, the briefing said. They'll fall out of the sky on their own. American bomber crews reported watching Me-262s approaching for attack runs only to see them suddenly trail black smoke and dive away, their engines failing at the critical moment. One B-17 gunner described seeing a 262 literally come apart in midair, its engine exploding in a ball of fire that consumed the entire aircraft in seconds. The Luftwaffe's own records, captured after the war, revealed the full extent of the catastrophe. JG-7, the primary Me-262 unit, lost more aircraft to technical failures than all other causes combined. In March 1945 alone, they recorded 46 engine-related losses versus 12 from combat. Maintenance crews were working around the clock, changing engines after every few flights. Some aircraft went through 6 engines in a single week. The joke among mechanics was that they needed 3 Me-62s to keep one flying, one in the air, one having its engines changed, and one providing spare parts. And they did. By March 1945, more Me-262s were being lost to engine failures than combat. Entire squadrons were grounded not for lack of fuel or pilots, but because no one trusted the engines. Mechanics would listen to the turbines, trying to detect the telltale harmonics that preceded failure. They developed elaborate pre-flight rituals, almost superstitions, believing they could somehow divine which engines would hold together and which would kill. Some pilots refused to fly unless their favorite mechanic had personally inspected the engines. Others carried suicide pills, preferring a quick death to burning alive in a cockpit when their engines inevitably failed. The most damning evidence came from Adolf Galland himself, the Luftwaffe's general of fighters. In his memoirs, he revealed that he'd known about the engine problems all along but was ordered to maintain pilot morale by suppressing the information. "We were sending boys to their deaths," he wrote, "in machines we knew were defective. It was murder disguised as duty." Galland himself, when he finally flew the Me-262 in combat with JV-44, insisted on having 3 backup aircraft ready at all times, knowing that engine failure was not a possibility, but a certainty. When the war ended, Allied technical teams descended on captured Jumo 004s like archaeologists discovering some ancient, dangerous artifact. What they found horrified them. British engineers at Rolls-Royce called them criminally unfit for service. American specialists at Wright Field declared that no Allied nation would have permitted such engines in operational aircraft. Frank Whittle himself, examining a captured 004, reportedly said, "This isn't an engine, it's a death sentence with a turbine attached." The detailed technical analysis was even more damning. Metallurgical studies revealed that some turbine blades had been operating so far beyond their material limits that they showed crystalline structures that shouldn't have been possible. The metal had literally been tortured into new configurations by the extreme stresses. Combustion chambers showed evidence of temperatures that exceeded the melting point of their construction materials, held together only by the constant flow of cooling air. One American engineer calculated that the 004 operated at 140% of what should have been catastrophic failure limits. It was, in his words, an engineering impossibility that somehow flew. Yet the 004's DNA lived on. The Soviets reversed engineered it into the RD-10, though they immediately addressed the material problems using their own alloy technologies. The French used captured examples to jumpstart their jet program, but spent 2 years just making them safe enough to test. Even the British and Americans, despite their horror at its reliability, learned from its innovations. The axial flow compressor design Franz pioneered became the standard for all future jet engines. The hollow turbine blade concept, once properly executed with appropriate materials, revolutionized turbine efficiency. The numbers tell their own grim story. Of approximately 1,400 Me-262s produced, fewer than 300 saw significant combat. The rest were destroyed on the ground, lost to accidents, or simply couldn't fly due to engine problems. Each Me-262 consumed an average of 6 Jumo 004 engines during its operational life, 2 to fly with, and 4 in various stages of overhaul or replacement. The total production run of nearly 8,000 engines managed to keep fewer than 100 aircraft operational at any given time. The human cost was staggering. While exact figures remain debated, the Luftwaffe lost scores of jet pilots to technical failures. Young men who'd survived years of conventional combat died not in battle but from mechanical betrayal. Their last moments were spent fighting unresponsive controls as their engines disintegrated around them. The psychological impact on surviving pilots was profound. Many reported nightmares about engine sounds for decades after the war. One veteran described how he couldn't stand the sound of vacuum cleaners because they reminded him of the whine that preceded a 004 failure. After the war, Anselm Franz immigrated to the United States, where he worked on developing the first American turboshaft engines for helicopters. He rarely spoke about the 004. When pressed, he would say only that we did what we could with what we had. But colleagues noticed he would become visibly distressed when discussing engine reliability standards, insisting on safety margins that seemed excessive even by American standards. His later designs incorporated triple redundancies for every critical system, a direct response to the horrors he'd witnessed with the 004. The Jumo 004 stands as one of aviation history's most complex legacies, simultaneously a breakthrough that changed everything and a cautionary tale about the cost of rushing revolutionary technology into service. It proved that jet propulsion was not just possible but inevitable. Every modern airliner tracing contrails across today's skies owes something to Franz's desperate innovations. But it also represents something darker. The 004 was a machine born from oppression, built by slaves, and deployed with callous disregard for the lives of those who flew it. It achieved its place in history through suffering, the suffering of the forced laborers who built it, the pilots who died in it, and ultimately the regime that believed technology alone could overcome its fundamental evil. Perhaps the most haunting aspect of the Jumo 004 story is how unnecessary the tragedy was. Had it been given proper development time, proper materials, and been built by willing workers in humane conditions, it could have been the revolutionary engine it pretended to be. Instead, it became a flying metaphor for the Nazi regime itself, impressive on the surface, rotten at the core, and ultimately self-destructing. The sound of a Jumo 004, that distinctive shriek that once terrified Allied bomber crews, can still be heard in museums where restored Me-262s occasionally fly. But now we know what the sound really represents. Not the scream of advanced technology, but the cry of an engine at war with itself, spinning toward inevitable failure, carrying with it all the contradictions and horrors of its creation. Modern jet engines, descendants of the 004, operate for thousands of hours between overhauls. They're built with precision by skilled workers in safe conditions, tested exhaustively before entering service. Every safety regulation, every quality control measure, every redundancy built into modern jet engines exists because of lessons written in the blood of Jumo 004 pilots. The 004 reminds us that revolutionary technology without conscience is not progress but catastrophe. The innovation built on oppression carries within it the seeds of its own failure. That the most advanced machine is worthless if it can't be trusted to carry its operator safely home. When historians debate whether the Me-262 could have changed the war's outcome if deployed earlier or in greater numbers, they miss the point. The Jumo 004 was never going to save the Third Reich because it embodied everything wrong with that regime. The rushed timelines, the disregard for human life, the belief that wonder weapons could compensate for fundamental failures of strategy and morality. In the end, the shocking truth about the Jumo 004 isn't just about hidden engine failures or sabotage or corporate cover-ups. It's about what happens when technological ambition divorces itself from human values. The 004 achieved the miracle of jet flight, but at a cost that transforms that miracle into a cautionary tale. Today, when engineers design new engines, they speak of Franz margins, safety factors that seem excessive until you remember where their absence led. Every time a modern jet engine runs for 20,000 hours without failure, it's a rebuke to the philosophy that created the 004. Every safe landing is a small victory over the ghosts of pilots who never made it home because their engines embodied the cruelty and desperation of their creators. The Jumo 004 changed aviation forever. It just didn't change it in the way its creators intended. Instead of being remembered as the engine that saved the Luftwaffe, it's remembered as proof that there are no shortcuts to excellence, no substitutes for integrity, and no technology advanced enough to overcome the fundamental requirement that machines must serve humanity, not sacrifice it. If this story of innovation and tragedy resonates with you, subscribe now. We explore the forgotten stories where engineering brilliance meets human drama. The history of aviation is written not just in successful designs, but in the failures that taught us what never to do again. What engine's dark secrets should we expose next? Let us know in the comments below. Remember, behind every legendary aircraft is an engine story, and most of them are darker than you'd ever imagine.